some slides. We'll go through some slides together. We'll see how far we get, and then we're going to go through some Alex topics, and then also more.
It smells like the advanced section. You put out ice cream. Exactly.
So we're going to go through chapter 11.
Like if you go to
No, 12. Chapter 12.
All
Alright, let's start with some rules. So we are now to naming. Or we're almost to naming. So this is kind of like a game. So think of the most recent board game you played and think about all of the rules that you had to remember. And if this happens, then you're going to follow this rule. If this happens, then you're going to follow this rule. This is the same thing in organic chemistry for naming, okay? So just think of it as a game. You are learning all the rules. You need to practice so that you know all the rules. So if something new comes up, you know the rules, just like in a board game, okay? All right, so today we're going to look at just naming, mostly naming chain, the long chain, and then some branches, and then we'll see where we are. So this is our goal. We're going to talk about normal alkanes. I think all of us have already done this because that was in chapter 11 topic. For some reason, that chapter 12 topic is linked to the 11 topics. I don't know if it's a prerequisite link or something. But this is going to be tested on chapter 12 test. Okay. Then we're going to talk about how to number the carbons in the chain. That's how we name them. So we need to practice numbering the chain. Then we're also going to look at finding the longest chain in a carbon chain, and then also looking at some common side chains. So we'll see where we get to. And we'll practice mostly in Alex. All right, so a hydrocarbon is, remember, only carbons and hydrogens. This suffix, ane, ane, tells us the carbon molecule, the hydrocarbon only has carbons and hydrogens, and it only has single bonds. So that's like the boringest organic molecule. Only carbons and hydrogens, no double bonds. This one is called undecane. Did that one show up for any of you in the chapter 11 assignment? Okay. Oh, Isabel found it. Okay. So on this list, you've probably already seen this because for some reason the topics are in a weird order. But this is linked to chapter 12 test. If the carbon has this many, if the carbon chain has this many carbons, we're going to name it based on these prefixes. If it only has single carbon-hydrogen bonds, then or carbon-carbon bonds, then we're using ane. Okay, so this prefix means there's one carbon, and then ane means it's only single bond. Very boring. Okay, for example, let's look at hept. I don't know. Have we talked about these prefixes before? I think when we did chapter 4, when we did naming covalent compounds. Hept is 7. Ane means it's boring. Only carbons and hydrogen single bonds. Okay, so this tells you a lot about the molecule, right? Okay. So these two down here are kind of weird. We've got decane, undecane, dodecane. These do show up. I've had people miss these on the test because they didn't think that dodecane was going to show up, so they didn't put it on their note card. Dodecane is a possibility on the test. Okay, not everyone will get that, but if you don't put it on your note card, you probably will get it. So that's how it works, right? So this is how we're gonna walk through some of these steps. We won't get through all of the rules. Okay. I think this is a good time to talk about. So we have chapter 12 and chapter 13. If for some reason you want to go ahead, all of the slides for chapter 12 and chapter 13 are up. You have all the information for chapter 12. So if you're really bored over spring break, you could go through and finish all of chapter 12 and all of chapter 13 if you wanted to. That's not required, definitely not required, but if you're looking to do that, all of the information is up for you. Okay, or Alex is pretty good, has pretty good explanations. All right, so when we're looking at a carbon chain, the first thing that we're going to do is we're going to find the longest the longest pathway through the molecule. That could be through a side chain. So we just have to find the longest one. Where are the carbons connected? And we're going to number them. We're going to number them. Let's see, number the longest carbon chain to name the alkane. Okay. Great. So let's see. We're going to do practice in Alex. All right. Once we have the longest carbon chain, we're going to number it based on the side chain. So either the carbon is in the main chain or it's in a side chain. It can't be in both. Okay. So for example, this molecule is highlighted. Everything here is the main chain. This is a branch. Okay. So it's either in the main chain or a branch. It can be in both. So then we're going to number the main chain to figure out how many carbons it is to see what prefix we should use for the parent hydrocarbon. Okay. So this one has 1, 2, 3, 4, 5, 6. So that's going to be hexane. But then we have to decide if we're going to number it from this way or from the right to the left. So what we're going to do is we're going to find the first branch. And we're going to make sure that that branch has the lowest number. So here's our rules, kind of weird rules. This is just like, remember, this is like a board game. We're just learning a game, all the rules in a game. So if I start this way, 1, 2, the branch, the first branch is at the 2 position. There's only one branch here. If I go this way, 1, 2, 3, 4, 5, 6, then the branch is at the 5 position. So I'm going to pick this numbering method because it's reducing the first branch. So that's our rule. Reduce the number of the first branch. Okay, we're going to practice in Alex. There's some examples there. All right, the next thing that we're going to talk about today is substituents. So on this paper, you have some substituents. This is one way to look at substituents. Alex uses this way. Alex just wants us to remember these 4. So methyl, we already know what a methyl group is. We have a carbon and 3 hydrogens. Same thing, methyl group is a branch. We saw that already. We won't go back. We saw that already in the notes today. If we have 1 carbon with 3 hydrogens in a branch somewhere, that's a methyl group. Okay. We also have an ethyl group. We're using the same prefixes also. So 1 for methyl, 2 for ethyl, 3 for propyl. So that's how many carbons are in the side branch. Propyl is interesting because once we get to propyl, we can connect the propyl either by the end of the propyl. So this is connecting to the end. Or we can connect to the middle of the propyl. So we have to specify because these have different properties. They'll have different reactivity. They'll have different chemical. They're different chemically. So we have to specify. This one would be isopropyl. This is just propyl, boring propyl. So make sure that that makes sense. This one kind of forms a T or like a Y when we're doing the skeletal structure. This one's some kind of branch. Okay. So all we're doing is we're counting the number of carbons in the side chain. The other substituent that we need to talk about is the chloro group, and that's also on here, but sometimes people forget. So that's also a side chain. There's all sorts of side chains. These are the only ones that we're going to learn in our class. So if you go on, if you take more organic chemistry, you will learn about more side chains. But we're going to stick with chloro, methyl, ethyl, propyl, isopropyl. Great. Let's quickly, I think the topics are in a different order than I have my slides. So let's quickly, we want to do naming. We'll come back. If we have time, we'll come back. All right, so what we're going to look at today is naming normal alkanes, which I think you have all done because that's in chapter, that was somehow linked to chapter 11. This is the topic. This one will be on the chapter 12 test. So be ready to name some hydrocarbons. So all we do is we count the number and then we remember or look at our note card and know what the name of that is. So this one has 1, 2, 3, 4. So 4 means bute. And there's no anything special, so it's ane. So have you heard of that before? Butane, butane lighter, that's butanes. Welcome, Ethan. Okay, next one. 1, 2, 3, 4, 5, 6, 7. So the prefix for 7 is hept. Oops. Hept over here. And then ane, because there's only single bonds, nothing else. If there's anything fancy, we will put it at the end, but nothing fancy. All right, this one has 1, 2, 3, 4, 5. So this is pent, ane. Oops. Okay, so I think we've all done this one already, so I'm going to keep going. We've got this one. Okay, I think I counted that one right. Hopefully I counted right. This is the topic that could have dodecane, undecane, decane, nonane. So those are all options also. So either memorize those or you can have them on your note card. Oops, okay, I'm going to here. Naming, do you have this one open yet? Naming and drawing normal alkanes? Okay, great. We'll do that one. Okay, so this is going to alternate between naming and drawing. This one also we're just counting the carbon chain. 1, 2, 3, 4, 5. This is pentane. 1, 2, 3, 4, 5, 6 is hexane. Oh, this one's really long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is decane. Some of these make sense. Some of them make less sense. Please spell it correctly. All right, let's try one more of these. We're going to draw. The next one is drawing. Okay, draw the skeletal structure. So remember, some of these questions, just pay attention. I think there's only one. One of them will ask you for one structure, but you can draw either. You can either draw the condensed or the skeletal. So make sure you're drawing whatever one they ask for. So skeletal, remember, is just the line, the stick one. Oh, here it's line. Okay. So octane, we need 8 carbons. 1, 2. I'm going to try my best to have those 30-degree angles. 3, 4, 5, 6, 7, 8. So I'm going to double check. 1, 2, 3, 4, 5, 6, 7, 8. If it has an even number, the ends will point in opposite directions. If it's an odd number, they'll point in the same direction. So that's another check. I would check many ways so that I get it right. Also, this topic, if you don't draw it how Alex likes it, if you draw it too steep, it will mark it wrong. So make sure you know what Alex likes for this topic. Okay, next topic. I think we can move on from that one. If you need help, let me know. We can go back. Naming and drawing small alkyl substituents. Okay, so this one we have to remember or write on our note card what the substituents are. So first, let's find the longest carbon chain. This one has 1, 2, 3, 4, 5. So those carbons are not substituents. Those are part of the main chain. Everything else is a substituent or a branch. So this is our only branch. It doesn't matter which direction I count it because either way it's at the 3 position. 1, 2, 3, 1, 2, 3. So this is a methyl group. This is a CH3 group. So I'm going to call it methyl. I'm going to spell it right. I'm going to tell myself that it's at location 3. Let's see how to do that one. Okay, if I had another branch, I could add a row. We don't have anything else. Let's do another one. Okay, this one also alternates between naming and drawing. So on the test, you probably will get one of each. So make sure you're comfortable with both of those. This one says, add a methyl substituent at carbon 6. 1, 2, 3, 4, 5, 6. It doesn't matter where I start. It's pointing up, so I'm going to draw my methyl group up. This one says, up propyl substituent at carbon 5. 1, 2, 3, 4, 5. So that's going to point down. It's not isopropyl, it's just boring propyl. 1, 2, 3. Propyl has 3 carbons. 1, 2, 3. My carbons are a little bit off, so hopefully Alex will like it. They're a little bit weird. They're a little bit steep. We'll see what happens. Okay. And an isopropyl at 4. Let's see. Add a methyl to 6. A propyl to 5. and an isopropyl at 4. 1, 2, 3, 4. So I'm gonna call this one 1, 4. And then isopropyl is the one that looks like if it's a skeletal structure, I'm gonna draw a Y. And then I can count 1, 2, 3. I have my 3 carbons. Okay. I am not liking this because their orders them at a higher number than I would like. We could order this lower than they did. So let's see what if I'm misunderstanding. Okay. So can you see how on this one they numbered it backwards? If I went like this, 1, 2, 3, 4. Oh, that's the same 1, 2, 3. Never mind. Let's see. I thought they were numbering it wrong. They numbered it fine. Okay, let's look at this one then. Both of these are 4. So which one wins? Which one should we number at the smaller number? What's another rule for our naming game? So this one is isopropyl. They put isopropyl at 4. And they put methyl at 6.
Left or right?
So it's if I flip this molecule upside down, it won't be left to right.
One.
Because it's just like geometrically I could. The molecule doesn't matter if it's like this way or like this way or upside down. So we can't always say that because maybe you counted from the right side. That's the same molecule. You just counted from the right side. So we have to decide on a rule. The rule is you're going to reduce, if they're tied, you're going to reduce a substituent that has that alphabetically comes first. So isopropyl, I, comes before M in the alphabet. So we're going to make this one at a smaller number if they're tied. So that's a new rule for our game. So keep track of that. All right, questions? Okay. All right, here we are. We have this long carbon chain. 1, 2, 3, 4, 5, 6, 7. So all of these ones are going to be in the main carbon chain. This one I'm going to put at 2. That'll win. If I count this way, this will be at 3. So I'm going to count this way. 1, 2. I have a methyl group at position 2. Methyl at position 2. And then this one has 2 substituents. I'm going to add a row. This one I have a carbon, a branch with 2 carbons. So this one, oh, and where was that? 1, 2, 3, 4, 5. Location 5. This is called 2 carbons ethyl. Ethyl is carbon. I feel like there's people who are named Ethel. but that's just a side name. Okay. Questions on this one? You think you can do this one? Okay. All right. Let's see this one. Naming the parent hydrocarbon of branched alkanes. So we have all these branches. All we're doing is we're finding the longest chain and we're numbering it. So this one, no matter which direction we go, we could go this way, 1, 2, 3, 1, 2, 3, straight through the middle, top down, 1, 2, 3. The longest chain I can find here is 3. So this will be propane. So if I'm naming the chain, it has ANE. That's the parent chain. If I'm naming a substituent, it has YLE. Or no E. YL. Like methyl, ethyl. This one we're naming the chain, the carbon chain, so it's going to be ANE at the end. Okay, this one, we're going to find the longest carbon chain. 1, 2, 3, 4, 5. If I just go straight through the middle, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So no matter which direction I go, no matter which path I follow, this is going to be, oops, don't capitalize it, pentane. All right, this one, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. So no matter which direction I go, no matter which path I go, this one will be butane, the longest carbon chain. Okay, let's try another one of these. Okay, 1, 2, 3, 4, 5. This one's pentane. Oh, this one. Can you see how this one has like an extra carbon down here? So if I go this way, 1, 2, 3, 4, I'll get the longest chain. If I go this way, 1, 2, 3, 4, that's also 4. 1, 2, I could go this way, 1, 2, 3, that's not the longest. 1, 2, 3 is not the longest. So this is the longest. 1, 2, 3, 4. Either way, I go there. Okay, 4. So butane. And then this one, okay, they kind of are trying to trick me, but I know that I'm going to look along the chain. So 1, 2, 3, 4. I'm not going to count 3. I'm going to use this as part of the carbon chain. 1, 2, 3, 4. So this one is butane. Also, questions on this one? Okay, do you think you could do this one? Even if it comes up with longer chain than we got? Okay, carbons. Numbering. Let's do this one. Yeah, we'll do this one. Okay, so this one, can you see how this one kind of wraps around? I think our longest is going to be this pathway. So they kind of bend them and shove them in this box, and we still have to look for the longest chain. And then we also have to reduce. We're going to reduce the first chain that we get, the first branch we get to, and then if it's a tie, can you see how this one we go 1, 2, 3? Oh, there's 2 methyls at the 3 position if we go this way. If we go this way, 1, 2, 3, there's only 1 methyl at the 3 position. They're both at the 3 position, so it's kind of tied. But this way is going to win 1, 2, 3 because I reduce 2 methyls instead of just 1. So the locant of the highlighted side chain is going to be 3. Let's do another one. All right, so find the longest chain. 1, 2, 3, 4, 5, 6, 7. So it looks like this pathway would be 7. Okay. And then along this chain, I'm going to find the branch that gives me the smallest first number. So if I'm going along my carbon chain, 1, 2, my first branch is at the 2 position if I'm going this way. 1, 2, and then this one would be at 3. So that looks pretty good to me. Oh, I think I skipped one. We'll come back. If I'm going this way, 1, 2, 3, my first branch is at the methyl group, but there's 2 of them, but they're at 3. If I go this way, my first branch is at the 2 position, so that's better. So I'm going to go 1, 2, 3. And it's asking you about the red one. It's not asking you to reduce the red one. It's asking you, when you name it correctly, when you number it correctly, where is the red one in your numbering? Okay. Let's go back to this one I skipped it. Oops. Okay, this one is, it looks like if I go along this path, that's my longest carbon chain. So these ones are in the chain, the carbon chain. These ones are branches. So I'm going to go this way, because this one will be at the 2 position. 1, 2, 3, 4, 5, 6. If I go this way, 1, 2, 3, then I have 2 branches at the 3 position, which is a bigger number than starting over here and getting this branch out at 2. So this will be at the 2 position, 2. Okay, questions? Should we do some more? Okay, let's do some more. Gotta make sure I'm doing it right. Okay, so this one, we're gonna find the longest chain. 1, 2, 3. 1, 2, 3. Oh, it's tied. The branches are both at the 3 position. So let's see, what's different about this one? Well, this one, I got 2 branches at the 3 position. So that way is going to win. I'm going to number it this way. 1, 2, 3, because now I have 3 at the 3 position. I'm reducing 2 methyl groups instead of just 1 if I go this way. So I'm going to go this way. 1, 2, 3, 4, 5. So this methyl group is at the 5 position.
But why wouldn't it be 3?
1, 2, 3. Yes, because this way is also 3. 1, 2, 3. And then there's 2 at this spot. There's 2 3s if I go this way. There's only 1 3 if I go this way. Oh, someone also thought of this. This makes sense to me. Someone also said, what if you figure out what position they're at and you add up the position? So this one is, if I go this way, 1, 2, 3, that's a 3. And then this one would be 5. So 3 plus 5 plus 5 is 13. If I go this way, 1, 2, 3, 4, 5. Then I have 2 3s, which is 6, plus 5 is 11. So that number is smaller. So then I will go this way because I achieved a smaller number with the branch numbers.
So you're just trying to get
Smaller amounts of branches.
not the amount of distance.
Not the amount of distance.
Oh,
The smallest number that the branch starts at.
okay, that makes more sense.
Okay. Okay. Yes. Confusing. And this also makes sense to me. So sometimes I'm not the best person to explain it because this makes sense to me and I can't remember how to explain it better. All right. So let's see this one. We've got 1, 2, 3, 4, 5, 6, 7. So I am going to number it this way because this will be at the 3 position. If I go this way, 1, 2, 3, 4, then this branch is at the 4 position. The first branch is at the 4 position instead of the 3 position if I go this way. 1, 2, 3, 4. So 1, 2, 3. So this one would be at the 4 position.
You know what? This sounds like something. So
1, 2, 3, 4. 1, 2, 3. I guess either way, this one's at the 4 position. The red one is at 4. Either way. But I would be numbering it this way. 1, 2, 3. Because this will be the first branch is at a lower number of carbon. Okay, can you see how this is kind of like a board game? Like if you pass the blue thing, then you do this. Like it's kind of like you're trying to collect these rules in your head. All right, let's do this last one and we'll see where we are. Okay, this one we have 1, 2, 3, 4, 5, 6, 7. So I could go this way. Or I could number it this way, 1, 2, 3, 4, 5, 6, 7. So either way, my first branch is going to be at the 3 position. Either if I go this way, my first branch is at the 3 position. If I go this way, if I number this way, 1, 2, 3, my first branch is at the 3 position. I'm going to go this way because that reduces 2 methyl groups to 3 instead of just 1. Or if I was adding, this would be, if I go this way, it'll be 3 plus 3 plus 5, or 3 plus 5 plus 5. So this way is going to reduce my overall number. So I'm going to put this one will be at the 3 position. This methyl is, if I number it correctly, will be at the 3 position. Okay, let's stop for a minute. Questions on this topic? Do you want to do more together? More together. Okay. Let's do another one. All right. So this one, if I go 1, 2, this one will be at the 2 position. Or I can number it this way. 1, 2, 3. Which way should I go? Yep, because that's going to make my first branch at the 2. 1, 2. Yep. 2. All right. Does this matter? This one doesn't matter. I could go 1, 2, 3, or 1, 2, 3. It's both up. This one will be at the 2 chain carbon. Doesn't matter. Okay, this one we could go. Let's see. Our longest carbon chain looks like it could be this one. Yep. 1, 2, 3, 4, 5. So I could either go this way. 1, 2, 3, 4, 5, or I can number it the other way. 1, 2, 3, 4, 5. If I go this way, then there's only 1 methyl group branch at the 2nd position. If I number this way, 1, 2, there's 2 methyl groups of the 2nd carbon. So I'm gonna go this way, 1, 2, 3, and then this will be at the 4 position.
How do you do this? How do you do this? Is it 4?
1, 2, 3. So look at the methyl group branches. I would go from the top down. 1, 2.
You get 5.
Yes.
Then you get these 2 out and that one out and just that one.
Yes. Yep. Yep.
Got all of them.
Let's see if we can find that one.
Because this one's 2, so this one's 2. And this one.
Skip.
This one's the strongest.
If the
Oh. How's this one over here?
Because it's.
Let's see if we can find one like that. I can't find one yet. I think it came up the other day. I don't know why. It's not coming up. Okay, we'll come back. Let's see, was that the last topic we're gonna go over? Okay. All right, that is the last topic we're going to go over today. Do you want to go over some more together of that one? Yes, that one? That is this one. This one?
Yeah.
Yes. So this is the last topic, and then next time, once we're practiced with this, we'll start talking about naming.
Okay.
We have to know how to do this before we can build the names. If you want to go ahead of us, feel free. All of the rules are on this sheet, or in Alex, or in the slides. Okay, so this one, let's see. We could go 1, 2, 3, 4, or we could go 1, 2. So I would go 1, 2. 1, 2. Yep. All right, so here, this one, it doesn't matter. 1, 2, 3, or 1, 2, 3. Either way, it's out of the 3 position. Yeah, I agree. Sounds good, let's do that. Okay, this one, let's see. We could go 1, 2, 3, 4, 5, or we could go 1, 2, 3. Yep, we'll go with the 5, good. Because we'll have 2 groups at this 3 position instead of, if we go this way, we'll just have 1 group at the 3 position. Yep, good. 5. 1, 2, 3, 4, 5. Okay. All right, how about this one? Yeah, I agree with that one. 1, 2, 3. Instead of 1, 2, 3, because there's 2 methyls at the 3 position. Yep. 3. Do you see? Do you see? So you just have to number the carbons. If it helps to write it out, maybe write it out. Should we write it out? Let's try that. The camera doesn't put that up. So we can go this way. 1, 2, 3, 4, 5. Or we can number it 1, 2, 3, 4, 5. So we're deciding which direction to number it. So if I go this way, my first branch is at the 2 position. If I go this way, my first branch is at the 3 position. So I'm going to go this way because my first branch is at a lower number. Does that help? Seeing it? A little bit? Okay. So this one, the red carbon will be at the 2 position. Because that numbering...
Oh! Genius! Genius!
Seeing it?
I was
Does
like,
seeing it
I thought
help?
we were counting? Okay.
We're numbering. Yep, okay. That's helpful to see. Okay, good. I'm glad that seeing it helps. Okay, so same thing here. This one doesn't matter. We can go this way. 1, 2, 3, or we can go 1, 2, 3. Either way, you get 2. 2. Okay. How are we doing now? Do you want to do another one together? Dilution. I can come help you with dilution. Any other ones up here for chapter 12? And we'll do naming next time. Yes. Yes. Naming and drawing small obstacles. Perfect. Oh yes, good. I'm glad. I forgot. We need to do this one. Okay. So actually, yes, we should have gone over this and we didn't. This is something that people miss on the test every year. This is like one of the most missed ones.
Wait, so why doesn't
So,
power for this one?
so notice this is all, they're all connected with 4 bonds. We have to add, so we have to take away hydrogen. So let's do that together. So add a methyl substituent at carbon 5. So it doesn't matter which direction you count. 1, 2, 3, 4. I'm going to put it here. And then this is a condensed structure, so I'm going to make sure that I put the CH3. But look at this carbon. It has 3 carbon-carbon bonds. 1, 2, 3. And it has 2 hydrogens. Yes. Yes. So you can just click on it and reduce the hydrogen like that. Yes, good. I think you're the only one who's going to get this one because no one else is listening. I forgot. So thank you for reminding me. Let's see. And carbon and ethyl at number 3. 1, 2, 3. Ethyl is CH2. Oh, I got CH2. CH3. And I need to go back and fix that. So you just have to make sure once you add something, you need to take a hydrogen off. If you add 2 things, you have to get rid of both of the hydrogens. If for some reason it said add 2 methyls at carbon 3 or something.
And then how do you know, does it matter if they go up or down? But the one that like I put one up, one down, I was wrong, so I went back to the
No, it shouldn't matter.
I never always missed the hydrogen somewhere.
Okay, yeah, it shouldn't matter. Yeah. And none of these have double bonds. It only matters if it's a double bond.
Okay.
And then they have to be on the same side. Yeah. But this shouldn't have any double bonds. This is all alkanes. In chapter 13, we'll talk about double bonds. Okay, so the important part of this one is that if you add something to the chain, you have to get rid of a hydrogen. So we already did that when you probably were not looking. We got rid of a hydrogen here because we added a branch here. We added we had a carbon methyl group here, so we had to get rid of a hydrogen. Carbon can only have 4 bonds, so make sure you show that. All right. Any other ones you want to go over? Okay, I will just wander around and answer questions.